How to delete rows from a pandas data frame based on a conditional expression. I have a pandas data frame and I want to delete rows from it where the length of the string in a particular column is greater than 2. I expect to be able to do this, per this answer. But I just get the error. What am I doing wrong? Note, I know I can use df.dropNet to get rid of rows that contain any nan, but I didn't see how to remove rows based on a conditional expression.
When you do len df column name, you are just getting one number, namely the number of rows in the data frame, i.e., the length of the column itself. If you want to apply len to each element in the column, use df column name, .map len. So try.
To directly answer this question's original title, How to Delete Rows from a Pandas Data Frame Based on a Conditional Expression, which I understand is not necessarily the ops problem, but could help other users coming across this question, one way to do this is to use the drop method. Example. To remove all rows where column score is lower than 50. In place version, as pointed out in comments. Multiple conditions. See Boolean indexing. The operators are for or, and for and for not. These must be grouped by using parentheses. To remove all rows where column score is lower than 50 and is greater than 20.
You can assign the data frame to a filtered version of itself. This is faster than drop. I will expand on it user's generic solution to provide a drop-free alternative. This is for folks directed here based on the question's title, not ops problem. Say you want to delete all rows with negative values. One-liner solution is step-by-step explanation. Let's generate a 5x5 random normal distribution data frame. Let the condition be deleting negatives. A Boolean df satisfying the condition. A Boolean series for all rows satisfying the condition. Note, if any element in the row fails the condition, the row is marked false. Finally, filter out rows from data frame based on the condition. You can assign it back to df to actually delete versus filtering done above. df equals df is greater than 0, all axis equals 1. This can easily be extended to filter out rows containing nan-s, non-numeric entries, dash. df equals df all axis equals 1. This can also be simplified for cases like delete all rows where column E is negative. I would like to end with some profiling stats on why a user's drop solution is slower than raw column-based filtration. A column is basically a series, i.e. a NumPy array. It can be indexed without any cost. For folks interested in how the underlying memory organization plays into execution speed, here is a great link on speeding up pandas.
If you want to see more, please consider subscribing.